I think the key decisions were made by the findings that we had, but I'll start from a little bit from the beginning. So when I started my lab at UCLA in 1984, I was really kind of decided to address the issue of immunological memory. And I was very fascinated by all the historical data that was there, that one could have very long-lived immunity against reinfection, or certainly against disease. So my question was, what is the cellular basis of this long-term immunity after an acute viral infection or after some of our better vaccines? So we really picked, and I decided that we would kind of pick a couple of good animal models for doing it, as opposed to trying to do too much. So most of the basic observations that we made on the maintenance of long-term T and B cell memory were really made using the mouse model of lymphocytic choriomeningitis virus infection. There's a very good mouse model to study basic T and B cell responses. And we continue to do that. So that still remains a major focus. And of course, we've expanded also into human studies for the last 25 or 30 years. But one thing that kind of was a interesting decision point or a change in direction was when we started comparing what happens to T and B cell responses, and in particular, what happens to T cell responses during a acute versus a chronic viral infection. And again, here the LCMV model was ideally suited for this, because there are strains of LCMV that cause an acute infection in mice and are very rapidly cleared within a week or two. And then there are strains that persist for several months, and in some cases even for the life of the mouse. So here we could study T cell immunity or T cell responses during acute versus chronic infection. And here we made the finding that if you have an acute infection, of course, you get long-lived and very functional memory T cells. And these memory T cells can be both circulating memory T cells as well as memory T cells in different tissues, but they persist for extended periods and remain highly functional, kind of ready to get again reactivated when there's a second exposure. But what we found was that when there is a chronic infection, then you start getting dysfunction of the T cells, and a very different program in doing an acute infection versus a chronic infection. And that was a major, I would say, a decision point or a change in trajectory from what we had initially started doing. And then that has been a very, I would say, half of the lab then started studying issues of chronic infection and T cell dysfunction and exhaustion. And in that period of studies that we did, these kind of linked it to PD-1, as PD-1 being the major regulator of T cell exhaustion during chronic infection. And that was the time then, we started getting some interest from the cancer community, because they had discovered independently from studies that very nice scientists in cancer immunology had shown that we also have T cell dysfunction in cancer. So that was another major decision thing that happened in my career, where we actually started studying human cancer. So I would say that these were two major transitions. One was changing our focus, just looking at immune memory after vaccination or acute infection, to what happens during chronic infection. And then actually starting to look at cancer because of the common mechanisms, common themes, common strategy for chronic infections versus cancer. And now our lab actually does a lot of human cancer, in addition to continuing our basic studies in using viral. I think the first thing I would tell a young academics and young scientist period is to pick a project that is of interest to the larger community. That is, pick an important project. Don't work on something that may be, not of such great interest. Is to pick something that's addressing a broad question and is an important question for the field. And then my second advice to the young people is to really focus, because initially when one starts out, we have a small group, don't have enough resources, is to ask a well-defined and focused question, pick the right model for asking that question, and move forward. And then the third advice I give to the young faculty just starting out is to continue working in the lab. That is not to just sit on the desk, because at least for the first few years, they'll be the best postdoc themselves in the lab. It means a lot. I think more, it means, I think more to me than somebody who's been a cancer immunologist most of their life. So as I told you, I kind of came in through the back door, and it's great to be accepted by the community as someone who's making a reasonable contribution. So it means a lot.